guys, welcome back to the Career Robotic channel. In today's video, we're going a fast and clear breakdown of the main coding languages used in robotics and modern technology. No theory overload, no confusion, just the essentials. If you want to build robots, control hardware, add intelligence, and create real application, this video will give you the full picture in a short time. Let's begin. Python is used for artificial intelligence, computer vision, machine learning, automation, and robotics logic. Robots use Python to analyze images, process data, and make intelligent decisions. It's flexible, readable, and essential for smart robotics systems. Arduino IDE is used to program microcontrollers and directly control hardware. Sensors, motors, LEDs, displays, and models respond in real time to Arduino code. It's simple, fast, and widely used in robotics learning, prototyping, and real projects. MicroPython brings Python into microcontrollers. It allows developers to program boards like ESP32 and Raspberry Pi Pico using Python syntax. This bridges high-level programming with embedded hardware. C is used in low-level embedded systems where memory and speed are critical. Many microcontrollers and real-time systems rely on C for direct hardware access and precise control. C++ is used in advanced robotics, real-time systems, and performance-critical applications. It's widely used in robotics frameworks and autonomous systems where efficiency is required. ROS is a robotics framework that uses Python and C++. It allows communication between sensors, motors, cameras, and algorithms. Autonomous robots, drones, and research platforms depend on ROS. MATLAB is used for robotics simulation, kinematics, dynamics, and control systems. Engineers test algorithms and robot behavior before deploying them on real hardware. Simulink is used for visual modeling and simulation of robotic systems. It helps design control systems and validate logic before implementation. JavaScript is used for web-based robotics dashboards, LOT platforms, and cloud interfaces. Robots can be monitored and controlled through browsers using JavaScript-based systems. HTML and CSS define the structure and design of robotics dashboards and control panels. They are essential for user interfaces and web-based robotics systems. Java is used in Android-based robotics control, enterprise robotics software, and industrial application. It provides stability and scalability. Kotlin is used for modern Android robotics applications. It allows efficient and safe development of mobile interfaces for robot control. Swift is used to build iOS applications that interact with robots. It enables Apple device-based robotics control systems. PLS languages such as ladder logic, function block diagram, and structured text are used in industrial robotics. They control robotic arms, conveyors, and automated factories. Lua is used in robotics simulation and embedded scripting. It is lightweight and often used for extending robotic systems and game engine-based simulation. Rust is gaining popularity in robotics for safe and reliable systems. It offers memory, safety, and performance, making it suitable for critical robotic applications. Go is used in robotics backends, cloud services, and LOT infrastructure. It handles concurrency and scalable systems efficiently. Shell scripting is used to automate robotics workflows, manage systems, and control deployments on Linux based robotic platforms. Flutter is used to build powerful mobile and desktop applications that interact directly with robots. With a single code base, Flutter allows you to create Android, iOS, web, and desktop apps for robot control. In robotics projects, Flutter applications are used to send commands, receive real time sensor data, display graphs, camera streams, and system status, and manage robot behavior remotely through Bluetooth, Wi-Fi, HTTP, web sockets, and MQTT. Flutter becomes the interface between the human and the robot. This makes Flutter essential for modern robotic systems where control, monitoring, and user experience matter. Robotics is built on many programming languages, each with a specific role. Python and MicroPython handle intelligence and logic. Arduino IDE controls hardware. Low-level languages power embedded systems. ROS manages complexity. Web, mobile, and industrial languages connect robots to users, factories, and the cloud. Understanding this ecosystem is what makes a real robotic. If this video helped you understanding robotics coding better, like the video, subscribe to the Career Robotic channel and activate the notification bell so you don't miss upcoming project. More robotics, more code, and more real systems are coming. See you in the next video. Bye.